Welcome back to a brand new installment. In this series of videos, we will learn to solve problems that involve linear, rational, and variable equations that, that have a solution, right? So without further delay, let's get started. Here's how you do the first problem. As soon as you see that there's a greater or less than symbol, you know for sure that it is part of the inequality concept. So that's the way you should approach it, irrespective of where the concept appears. So we have 3 minus 3x is less than 20, right? So we want to get rid of the 3 first, and we can do that by adding -3 on both sides, which would make it less than 17. Now we have to get rid of the negative and the 3. So if we just simply divide by -3 on both sides, then we will just have the x. But what happens is, because we are dividing by a negative symbol, or multiplying for that matter, you have to reverse the sign of the inequality. So x is greater than -17 over 3, right? 17 over 3, I believe, is about 5.7 or so. So in other words, x is greater than -5.7. When you say x is greater than -5.7, then you're not thinking 6.7, 7.7. Instead, x is greater than -5.7, so x could be -5, -4, -3, -2, -1, 0, so on, right? So if you look at all the answer choices, these numbers that I've written, they capture pretty much everything that's on this list except for one, and that's the answer, which is x equals -6, right? Let's continue. Let x be a number. Increasing x by 20% yields that same result as decreasing the product of 4 and x by 5. What is x, right? I think I've mentioned this before when we learned word problems. Is you need to figure out a way to write what's in words into an algebraic expression. So let's tackle the first portion, because there's two parts to it, right? We are increasing x by 20%. So that's exactly what you should do. So if x is increased by 20%, that means x plus x times 20, right? That's what it literally reads. So for some of you that are still wondering, how did I get here? Let's say a product is, say, $50, okay? I'm not trying to deviate from the problem. I will get back to it, but I want to make sure that you understand, okay? If the product is increased, if the cost of this product is increased by 20% from, say, month A to month B, what happens is you have to multiply by 20%, which is 0.2, right? Which is 50 times 0.2 is 10.0. So it's increased by $10. Now, what most of you might be thinking is, why is it added back to the x? I've already done my discount, or whatever the rate that's gone up. Well, you only accounted for the portion where the cost is either gone up, or if it was a discount, then you're just simply looking at the discount. You're not looking at the grand total. The only way you look at the grand total is you take the $50, which was the cost of the product in month A, and you add the $10, so that makes it $60 total. This is exactly the premise around which this was written. The only thing is, this is generic. This is a specific case. Now, if you have to do something like this to get back to this on a test, do so by all means if you have time. If you're out of time and you really have a few more problems that you can do, then go ahead and skip this for just time being. Go ahead and solve the ones that you think you can do and come back to it if you have time. Or if you can just jump straight into it, if you understood the logic, then this problem is very simple, right? So here's how you do it. And this is nothing but x plus 0.2x, right? So you can take x out of the bracket, which would leave you with 1.2. So essentially this is 1.2x. That's one part of the problem. The second part of this is decreasing the product of 4 and x by 5. Okay? Simply understand and write it the way you see it. So it's like calligraphy if you think about it. Product of 4 and x, which is x times 4. Okay? Decreasing the product of x and 4 by 5. That means 4x minus 5. Okay? Essentially, we have two components, and we're saying these two are the same. That means they're equal. That's what you have to know. So that's equal to 4x minus 5. So you can bring 5 to this side and I take the x to the other side. So 5 equals, what is that? 4x, 4 over 4 minus 1.2 is 2.8, right? So x equals 2.8, or sorry, 5 over 2.8. I believe on this particular problem, it was left as it is. They didn't really make any huge adjustments. They left it as it is. So the value of x is 5 over 2.8. Okay. And that's how you do it. So understand, and when you encounter this sort of problems, it's better you break it into pieces and try to solve the problem. Right. If 4xs equals v equals ks, and then sv is not equal to 0, which of the following is equal to k, right? We know that we want to find k. So where is k? K appears in the expression v equals ks, right? So we want to find k. That means we have to substitute in such a way that the new expression contains k. Only then you'll be able to solve for k. So how can we do that? Well, if I have to make a substitution of k into the only expression left, it contains 4xs, right? So if I have to convert this in some way to get it into this one, it only contains two terms and only one of the two terms is present here, which is s. So if I can make a expression that has k or yes in terms of k, then I can substitute that into this expression and then I can solve the problem. So in other words, if you divide by s on both sides, then v over s equals k, right? Now we have v over s equals k, but is that what we want? Actually, I did the other way around. So I should have done the other way around, sorry. So let's strike this off. We want s, which is v over k. So if we divide it by k on both sides, then we get v over k. Then I substitute this in this expression here. So it's 4 times x times v over k, right? Now that's equal to v, right? So v and v cancel out, right? So 4x equals k. That's it. Now you could have also be wondering, well, I could have done this instead. Yes, I did not think that initially. We know v equals ks, so you can simply do ks on either side and then 4x equals k. Not sure how I missed it. I think that's because maybe I didn't see the v in front of the 4xs. So that's one way to do it. Actually, two ways to do it. So if 2x squared times 5 minus x times 3x plus 2 equals 0. What is the sum of all of the possible values of x? This is a very easy problem. You might think, do I have to multiply through the entire expression and then get it into some form? No, you don't have to. Each of these terms is equal to 0. That means, remember, we did this sort of problem on the videos on factoring. So if you're wondering, I suggest you go back to my videos on factoring, then you'll see we have done this sort of problem. So we know when you have this sort of expression, then you can equate each of this expression to 0. When 2x squared equals 0, x equals 0. Simple. 5 minus x equals 0, x equals 5, right? 3x plus 2 equals 0, 3x equals negative 2, x equals negative 2 over 3. Now they're asking, these are the values possible. What is the sum of all possible values of x? So we have to add 0 plus 5 minus 2 over 3. We don't need to worry about 0. So if we take the common denominator as 3, then it's 1 times 3, 3 times 5 is 15, minus 2 is 13 over 3. Isn't that simple? But again, I told you to go back and watch the videos on factoring if you're still having trouble with this sort of problem. So if you do that, you're going to greatly benefit, right? Let's go continue. So we have square root of x squared minus 7, that's equal to 3. I've repeatedly said, when you have a square root on one side and you have nothing on the other side, your best bet is to take the square on both sides, not square root, square on both sides. So if you square both sides, you get rid of the square root, which leaves you with x squared minus 7 equals 9, x squared equals 16, x equals square root of 16, which is plus or minus 4. Isn't that simple? This is the end of this video. We'll have more videos on this topic. So let's get going. So we have square root of 8y plus 18 equals 4, right? Again, your best bet is not to take the square here, because then it gets into a plus b whole squared equals a squared plus b squared plus 2ab, which makes the problem excessively long. You don't want to do that, okay? You only square both sides if it's like a equals b. If you have something like this, then you are better off squaring, which is you square both sides and becomes a equals b. That's not the case what we have here. Here you have to actually simplify these terms. So 8y equals 4 minus 18 is negative 14. Then take the square root. Now we have it in a form which is very similar to what we have here. Now if you square on both sides, it will be 8y equals negative 14 square. I don't know on top of my head. It's 14, it's 196. So 8y equals 196, y equals 196 over 8, which is 24.5. Right? Got one more problem. Give f of x equals x squared minus 9. What are the zeros of the function? Well, it's a very, very simple problem. They're saying they're not saying x equals 0, they're saying the function is equal to 0. There's a difference. The question is not saying the variable is not equal to 0. That's not what it's saying, okay? This is not what it's saying. It's saying the function itself is equal to 0. There's a difference, okay? So if that's the case, then f of x equals 0, that means x squared minus 9 equals 0, x squared equals 9, x equals square root of 9, which is plus or minus 3. And that's the answer, right? Thank you for watching. I'll see you with another video on linear, rational, and variable equations with solutions. So please stay tuned.